Hi, this is Nikhil. I was an intern at Mozilla for the summer of 2011, and this is basically a presentation of what I did here. So I hope you enjoy it. Here goes. My work was primarily with implementing type diaries and binary data in JavaScript. So, if you see JavaScript as a language, it started out as being a language to manipulate the DOM in Netscape. And because of that, it doesn't have very good type support. There's no concept of data types. There's only numbers and strings and a few other objects. And so when you say a number, it's just a number. There's no concept of unsigned int or a float 32 or a float 64. And while that is all well and good for most applications, with the current usage of JavaScript as it becomes a more mature and general purpose language, it's not really, the data types we have are not sufficient enough. For example, when you use JavaScript for system software, as in Node.js, where you do a lot of input output and file IO, you need dedicated binary types. JavaScript strings are UTF-16, and they don't really offer support for handling binary data. So, or if you look at the web browser with modern technologies like WebGL or Audio API, you need something that can guarantee the data type. Like if you have an array of floats, it can probably optimize. The code can probably be optimized to work faster. That's where we enter type diaries. This has been in Firefox for quite a while now. It was originally pushed through when WebGL was implemented, and it is now used by the Audio API, the File API, and the soon the XML HTTP request API. Uh, what it allows you to do is to specify an array of a certain data type, like in this case, float 32 array of a size 100. And the difference between this and a normal JavaScript array of size 32 of floats is that it is contiguously allocated in memory, which means that each element of the array is next to each other in memory, and that gives a really huge speed advantage. And it allows you the processor to do something like what is called single instruction multiple data, where you can pass an entire chunk of memory to the processor and it does some operation on it. And it also enforces types. Like if you say that a array is of unsigned int 8 and then you try to put a number like 65,000 in there, it won't allow that. So you get like type checking and safety instead of it just being a number. So my project, my first half of the internship was to optimize type diary creation, and to do that, I had to stick things into inappropriate places. The basic implementation of type diaries used a lot of plain C++ objects and heap allocation, which led to a number of memory allocation requests that slowed down creation. So uh, I basically removed some of that, then tried to use a lot of empty space that is there in the JavaScript engine due to the way SpiderMonkey is designed to store data where it like there was free space which wasn't being used. And while doing that, I had to, since I was changing some pretty low level parts of the way JavaScript objects were supposed to behave in the engine, I had to write code to handle all the problems that could occur if not handled properly. And then I also had to modify both the just-in-time compilers, which are TraceMonkey and JagerMonkey, to generate the right code now that the way typed arrays were implemented had changed. So typed array improvement should land in both Firefox 7 and 8. Here's a graph showing the performance improvements for creation. So the orange patches will land in 7 and the yellow patches in 8. Uh, if you see the axis graph, there's a huge difference between the orange and the yellow graphs. That is actually because Jaeger Monkey did not have a uh, fast code path to get the length of an array, which is commonly how arrays tend to be used in for loops. And I added that, and that should give a great improvement when trying to loop over arrays in an inefficient manner. Now, the problem with typed arrays is that they are only arrays. You can't have just one integer of size 16 or one float of size 64, and they don't allow you to have something like JavaScript objects with well-defined types. So that is where we enter a new proposal, which is part of ECMAScript Harmony, called binary data. The specification is still being fleshed out by Dave Herman, and my job was to make a preliminary implementation to just allow us to play around with it. So instead of having just arrays, binary data introduces certain primitives like you see on screen. For example, int 8, which is an integer of size occupying just 1 byte. And you also have something called a struct type, which is like a normal object literal in JavaScript, as you can see on the second last line. But it has named fields instead of just indices. But each of these fields has a concrete numeric primitive data type rather than being a number, which allows you to do pretty interesting things. And the other main important point is that if you create this structure, the entire structure is continuously allocated in memory. So that is a use speed improvement, and it allows you to do a lot of binary data related stuff like writing to a file or reading from a file. So I don't have a demo to run of this on this computer because it requires Firefox nightly. And the status of binary data is highly experimental right now, but I do have a usable implementation, which you can find at the URL on the screen. The code is pretty dirty right now since it was a proof of concept, and there are memory leaks which I am currently fixing. There is no just-in-time support yet, so binary data is slower than normal data, but that should be fixed soon because the entire point of having binary data is to have fast type-safe access to certain for certain uses of JavaScript. So there are also plans to interoperate between binary data and typed arrays because typed arrays are like going to be in JavaScript for quite some time. There, I don't think there's any plan to remove them once binary data goes in. And what we would like is for array buffers and typed arrays to be convertible to binary data and back, so that you could send stuff over the wire and like get it back to a structured form on the other side. There's no current plans to ship binary data at any point in the future. So uh, until the ECMAScript spec is finalized and Firefox itself moves to implementing Harmony into the SpiderMonkey. So I had great fun here, and I hope you enjoyed the presentation. Thank you.